Welcome to Brain Vision.
Problem 7.39. So we have a block on a table with friction and a spring. And so we take the block and compress the spring by 0.2 meters, spring constant of 100 newtons per meter. We release it from rest. So its initial speed is 0, and then 1 meter later it comes to a stop. And we want to find what is the coefficient of kinetic friction between the block and the table. So we want to use conservation of energy. So we know the initial potential, kinetic energies, and work done between the beginning and end is equal to the final potential and kinetic energy. So because the block is at rest in both of the initial and the final states, there's no kinetic energy. The only thing in here that has any potential energy that we're concerned with, because this is horizontal and so there's no changes in the gravitational potential or anything like that, is the elastic energy in the spring. No spring is being compressed over here. So the total energy is going to, the potential energy plus the work done by friction has to add up to 0. So this is equal to the negative of the work, which is done by friction. So the spring potential energy is 1/2 kx squared. X will be our 0.2 meters. K is 100 newtons per meter. This has to be equal to, now the work that friction does is negative mu times the normal force times the distance. So we get two negatives, which cancel. Our kinetic coefficient of friction that we would like to find. The normal force, this is horizontal, so it's just the weight. And then we'll call d our distance of 1 meter. So, fairly straightforward, we solve kx squared over 2mgd. Put in all of our numbers for these things, and we find that the kinetic coefficient of friction is 0.41.